we might as well start. Those of you who are standing, you should sit down, I think. I'd like to welcome you to I think this is the 9th workshop held at Johns Hopkins. There were 2 previous ones that were held at Rutgers, but the 9th that is here. So next year will be our 10th anniversary year. I note that it's Bastille Day today, another significant day. Anyway, this is our program, and roughly speaking, there'll be all sorts of addresses to you, and then there will be descriptions of various projects, and we're going to be open to questions, and eventually we will give you some information about the administrative and technical content. So I want to tell you something about how this all started, etc. Can we switch now to my... Ah, yes, right. So this work that's going to be going on in the next 6 weeks was planned at a planning meeting held in some place called Turf Valley that took place 3 days. We received 11 proposals about what the work should be about. Of course, there were people who had other ideas that came too and did not formalize them. We invited 27 people to come and have a discussion as to what the aims of this workshop ought to be. And out of all these discussions and 3 days meeting, there came out 4 projects that seemed worthy of pursuing, and they are listed over here. Syntax for machine translation, semantic analysis over sparse data, dialectical Chinese speech recognition, and confidence estimation for natural language applications. The details of what this is all about you will hear later from the people who are the team leaders. We also chose team leaders at that meeting. In the spring, we didn't just let the past go, but the teams were preparing what to do here. First of all, the teams were chosen, completed. Undergraduates were added through international competition, which had, I don't know, something like 120 applicants, and we chose 8. So this is really an elite bunch that we have here. The 3 teams had 2 meetings each to refine and design the tasks that they're going to be working on. Unfortunately, because of the SARS epidemic, the 4th team was not able to meet, and so we postponed the work of the 4th team to next year. The result of all this is that we will have here 34 participants, 14 of them are professionals, 12 graduate students, and 8 undergraduates, and these are the other demographics. There are 9 different countries. I don't know if this is 9 or 10. I don't know if I counted US as one of the countries, but anyway, these are people who are participating here. And this is what you can expect in the next 2 weeks, besides the work of the teams, and that's we'll have every Wednesday we'll have a seminar by some eminent speaker that we will have chosen jointly, not necessarily relevant to any particular work going on here, but generally of interest to what we think are your interests. Each Wednesday there'll be an update on the team's progress, not every team, but some team's progress, and we will have all a common lunch where we'll mingle and talk about the progress and about the work that was presented by the speakers. Every day we'll have a cookie break where we hope that people will interrupt their work and talk to their colleagues. We go out usually to dinner on Thursdays. We don't force anyone to come with us. The students are usually our guests. we meet with the undergraduates on Thursdays also for a brown bag lunch to see whether they are making progress and how much they understand what's going on and what it is that they are contributing. They give us talks about their work. And Friday afternoon we end the week by a social with upgraded goodies like ice cream and cake, etc. Finally, what you can expect is that at the end of the workshop there'll be 2 days of presentations of what it is that the teams have accomplished. And the graduate students who might want to continue the work will present proposals to an independent panel that will appoint, when I say independent, people who are not participating in the workshop, and that will be nominated by the various team leaders, and we will be able to, we have money to be able to finance 2 or 3 projects of these graduate students for the following week. So this is my introduction, and I think, well, if there are any questions, I'll be glad to answer them, and otherwise our Dean for Research, Mark Danahue, is going to talk to you.
Thank you, Fred. It's a pleasure to be here to address this group. Fred mentioned that this is the 9th of these workshops here at Johns Hopkins, and I want to say that I think that the CLSP workshops have been a really remarkable success and more importantly, a remarkable model. The nature of science and engineering research has changed over the last 10 years, and it has gone from being an individual exercise to being a collaborative exercise. And if you look at the government agencies, and it doesn't matter whether you look at NSF or the Department of Energy or the Department of Defense, or it doesn't matter where it is, everyone is emphasizing the teaming between industry, government labs, and academia. This is really the buzzword at every single federal agency. And CLSP was on the cutting edge of this. CLSP has been doing this for a long time and has been doing it very successfully. And I think what's very interesting about this model is not just that CLSP has been able to integrate academia with industry and government, but has been able to integrate faculty and other researchers with graduate students and undergraduate students. This is a really remarkable model, and it's something that Johns Hopkins is very proud of, and I think CLSP is very proud of, but it's also something that I think that you should be proud of participating in. And so on behalf of Johns Hopkins and the engineering school, I want to welcome you, and I hope you enjoy your 6 weeks here. Thank you.
Our sponsor, Jen Garb.
Good morning, everybody. Yes, it's my pleasure to serve as the government representative on the contract that supports the center. And I guess it's in that guise that I'm here to open up the workshop. It's a pleasure to support the center, and the workshop is one of the premier activities made possible by having a stable center. It occurred to me while Mark was speaking, it's true that the collaborative paradigm has become very important in science and engineering over the past 10, 20 years. But think how difficult it is to create such a collaborative environment when you have to do it intermittently, once a year for 6 weeks. It's been a remarkable achievement. And those of you who don't know, I suspect most of the people in this room do know, apart from the short remarks that Fred made, an enormous amount of work goes into organizing and preparing and, as I would say, teeing up the problems for the summer. I mean, we try, the process begins immediately after the workshop ends for the next workshop, as many of you know. It begins seriously by October, and then continues from that choice, from the time we choose the teams, right up to the workshop. And so I'd like, on behalf of the government, I'd like to express My deep appreciation to all the people who worked so hard to make that happen, Fred and Sanjeev and Bill and so forth, and also the staff members. But you know, we tried to choose problems that are ripe for some kind of a research attack, but also problems that are likely to have impact and that have educational value. And all of those factors are taken into serious consideration in the choice. The students especially should appreciate that. And as Mark said, there have been some remarkable successes, some of them measurable in terms of papers published and explicit findings made during or shortly after the workshop. But I think there are many other more subtle effects in the form of students who've gone on to take interest in these problems and teams that have collaborated. There's a remarkable amount of cross-university and cross-institutional collaboration that's initiated by these workshops. And if there's one message apart from work hard and have fun, it is, I hope you'll keep track of the ideas that are generated within and across teams during the summer. Keep track of them, follow them up during the year following, and let us know about the progress that you make on them. So, work hard and have fun. That's our theme.
Now we have Sanjeev, who's going to tell us about the previous 2 weeks, right?
Yes, the previous 2 weeks, and in fact, a little more than the previous 2 weeks. I think a couple of the speakers already touched on this point, that people think of this as a summer workshop, and I think that's a little bit of a misnomer, because summer is when the visible part of the workshop happens, and in fact, a lot of things happen before the summer. So this is typically how our year goes. We start, as we said, the call for proposals right away in September, and in fact, this year we've had an early start. We started it in July. So there's already a call for proposals out there on what to do in the summer, and then the proposal deadlines are typically in October. We review them. Fred already mentioned we have a review meeting in November. Usually, if everything goes well, the money shows up from NSF in December or January. This is when the fiscal budget is approved in October. By December or January, the money comes to us. We form the team, so on and so forth. And I'll tell you a little bit about these things. And this is the part that you will all see. But I want you to know that there's a lot of stuff that goes on before that. So I already mentioned this a little bit. This year, for example, the call for proposals went out on 26th of August last year. It was electronically advertised to hundreds of people. We even got hold of some of our program managers and asked them to send the announcement to their contractors, saying if you have interest in ideas, send it to Hopkins and see from the team. We actually had 18 proposals, of which we threw away some of the clearly unviable ones. For example, there were some proposals that said, oh, I'm not going to be there in the summer, but this is a great idea, see if you can go find somebody to work on it. So things like that we simply put aside, because it really requires the originators of the ideas to push the proposal along, and that's always been one of our requirements. And there was a 2-day review meeting in November. Again, Fred mentioned this, and the 4 proposals that you heard of were chosen. This is a quick preview of who was there at the team meetings. So for example, there are a lot of people like Jim Baker and John Shore and Jordan Cohen, who are basically well-known figures in the field who have done some good work, who are not necessarily involved in the proposal, so they acted as sort of objective reviewers. You can also see many of the people who are now in the workshop over there, because they were the people who proposed these ideas, and they were invited. There were a few government people and a few Hopkins faculty, and this sort of acted as a peer review team to try and evaluate these proposals. The proposals that were on the table on that day, the 11 of them are right here. I've listed them by one of the authors or the principal author of the proposal. A plus means there were other people involved in writing it. And then these proposals were debated. As you can notice, there are several similar proposals. So Gildea has loosely tree-based statistical machine translation. Ott has syntax for statistical MT, and so on and so forth. And people realized that it would do work well to just team up and have a single proposal. Some of that happened, some voting happened, and in the end, these are the proposals that survived or that got voted to the top. So Roberto Basili and Luis Guthrie formed a team which is called Semantic Annotation from Sparse Data. George Foster's team is working on conference annotation and so on. And this is the team that would have come here and worked on Chinese dialectal speech recognition, except now it will happen next year. So once the teams were formed, the senior members were selected more or less by Christmas, the grad students in January, February, and the undergraduates in March. Here has already covered the demographics. And the teams met, I did not have some figures. Every team had at least 2 face-to-face meetings. And for example, the MT team met once in Los Angeles and once in Edmonton. The semantic annotation team met once in Sheffield and once in Rome. And besides, there were other smaller meetings at conferences and so on. And this is all the preparation that goes on even before people come here to Hopkins. And then finally we're here, and now we're in the beginning of, at the end of June. So this is something that started a few years ago when we started having undergraduates. We realized that we had to have some kind of tutorial to bring them all up to speed so that they could participate fully in the workshop. And this was essentially something we started just for the workshop undergraduates, but over time we found that more and more people were interested in it. We'd often get DoD representatives coming in just listening in to sort of catch up with what's going on and so on. And then finally last year NAACL jumped in and said, we'd like to send students to this as well. So right now we've got this fairly large activity where we have more than 30-some students. In fact, the classroom holds 40, and every day at the lecture, the classroom would be overflowing. So this is the summer school as it has come to be known. And this is what we had this year. So we had a day on natural language processing where Chris Manning and Jason Eisner gave lectures and then organized the lab. We had a day on speech and music signal processing where Bill Byrne talked about speech recognition and Dan Ellis about analyzing music signals. Then we had a day on information retrieval where Jim Mayfield, David Yarowski, and Philip Resnick covered both the monolingual and cross-lingual information retrieval. Then we had a day on generation and summarization. We had Regina Barzilay, who's now at MIT, and Drago. They put together a nice series of lectures and labs. One fun thing we had this year was a lab on spoken dialogue systems. We had Stephanie Seneff and Grace Chung. Grace is now at CNRI. She used to be a student at MIT. They put together a lab in which students actually designed a dialogue system out on a server at MIT, then called it up and tried to talk to it. So that was a nice exercise. We had a day on machine learning. Ray Mooney gave a series of lectures, one on just basic machine learning ideas, another one on applications to natural language. And then Jeff Burns conducted a lecture in a lab on graphical models. As some of you may know, they have developed a nice graphical modeling toolkit, and people use that to learn how to use graphical models in various applications. And then the last 3 days were dedicated to the teams, trying to bring all the students on par, sort of making sure that the students know what the other teams are doing. So we had one day on syntax and machine translation where Kenji and Anoop gave a lecture in a lab. And we had Salim Rukos from IBM come and talk about the translation effort that's going on at IBM. Then on the 11th, we had a day on confidence estimation where George and Simona talked about what their team was doing, and we had Joshua Bengio come and talk a little bit more about machine learning and neural networks, the core ideas that they are going to use in the summer for their team. And finally, on the last Friday, we had Ralph Krishnan and Doug Apple come and talk about information extraction and semantics for the purpose of information extraction. And then Louise had a lecture in a lab on what her team is going to do. The students got to segregate, get around with a little bit with annotations and disambiguate the senses of words based on context and so on. So this was our summer school.
If you're off in your days, you know that.
Am I?
Yes. Friday was July 11th.
Oh, okay. I must have skipped a day somewhere. Sorry. Well, the days are right. The days, you know. Okay. And then this is what is coming up. So we are up there on the 14th of July, and this is what the next 6 weeks are going to look like. So there are some, of course, recurring themes over here. One thing to note is every Wednesday there is going to be a seminar. It'll be just before lunch in the morning, something like 10:30 to 11:30 or 11 to 12. And we're going to have some eminent speakers come and talk about things that excite them at the moment. We're going to have Jim West this Wednesday. He used to be at Bell Labs. He's now here at Hopkins, and he's working on acoustics, and he's doing some pioneering work in microphone-based speech recognition. Next Wednesday, we have Herman Nair from Aachen, who is, of course, a well-known figure, worked on many aspects of natural language processing and lately machine translation. And we'll have the other speakers announced as soon as we confirm details. Thursday, Fred mentioned we're going to have the optional group dinner. Thursday lunch is when the undergraduates get together and try to figure out how deep how deep in trouble they are and whether everybody else is feeling as overwhelmed as they are, which usually is the case, but in the end, they all really do really well. And Fridays, we have the fancy desserts. We also have a town hall meeting, meaning that's the time when you all come together and it's time to air your views. Oh, the room is very hot. Somebody needs to do something about the air conditioning, or like, I'm going off to Philadelphia this weekend. Does anyone want to go with me? So it's just an open forum where people can talk. And of course, there will be other problems to discuss. The computers are misbehaving or something like that. And that's the time to air all your views and talk to everybody else in the workshop. In addition to the usual 3 o'clock cookies. And finally, for the team leaders, there is something called a steering committee of which you are de facto members. And this is again a forum where you get together to thrash out any workshop-related issues. And that committee meets every Monday at a time which is chosen at our meetings. So this is what is up front. And for those of you who are not in the workshop, these are the 2 days to mark. August 20 and 21 is when we'll have our final presentations. These will be day-long events. And this is when you'll hear the results of all the effort that's gone on from last December, January until now. And so those of you who want to make a note on their calendar, these are the dates to look out for, in addition to the Wednesday seminars if you want to attend. By the way, all these events, the Wednesday seminars, the presentations, are all open to the public. So if other people in your organization want to come along, please invite them up. Thank you.
I should say that nobody should think that there won't be any team updates on July 30th or on August 13th. I'm sure will be.
Yeah. Let me also say that this is basically what is definite. We might add things to it. Last year, for example, we felt that would have been adequate, so that's what we did last year. Every year we sort of sit down, and that's what the steering committee does. We decide if it's time for an update, and if there is, Wednesday is the time.
And there is one more thing. I mean, usually we have participants who feel that they have something to tell us. And so we have extra lectures by people who either because we uncovered that they have techniques that might be of interest to everyone, or we on the other hand feel that we would like to learn something and we locate someone who knows it. So there are additional lectures during the week that take place. And anyone who would like to volunteer a lecture to us, please should contact us or contact at least a member of the steering committee so we can take it into account. We're always eager to have a little bit of an interruption, and which will make us better people. Okay, thank you very much. We're now done with the introductory session, and now I guess Franz Josef will tell us about machine translation.
So I'm going to talk about the workshop Syntax for Statistical Machine Translation. So here I put on the beginning slide all our team members, team from various different, I think I should turn this on. Is it working now? Or? Team from various different locations. So we have 5 research members, 4 graduate students and 3 undergraduate students, and an additional associated member from Math University who's very interested in the topic too. So here I will first talk about the problem that we are facing right now with the existing state-of-the-art statistical machine translation. Talk about the methods used and the problems with respect to errors that the system right now makes, and then suggest the solution which we will pursue in the workshop, and to discuss then the progress that we have made so far in the workshop preparations. So in statistical machine translation, we have basically 3 different tasks that we want to pursue. So one is modeling. We want to model a probability distribution which relates foreign language sentences and English sentences. And this model has 3 parameters. And then in a training procedure, we train these 3 parameters such that some criterion gets optimized. So typically that might be maximum likelihood criterion. Ideally, we want like to optimize that we get a high quality translation. And then there is a search process where we then have a procedure which, if we get new sentences that we want to translate, that we use the translation of these new sentences. There are additional important tasks like data acquisition, we need training data, pre- and post-processing, evaluation. And for the workshop now, we are going to work mainly on the modeling aspect, so we describe then the form of the kind of dependencies that should be taken into account, and hopefully we find better dependencies than are used so far, and to a lesser extent then we will work on training and search. And all the other important tasks are already pre-done, so we have a lot of data that is set in pre- and post-processing, evaluation procedure. And so to the modeling. Very nice approach to deal with statistical machine translation models are the so-called log linear models, where we have a set of feature functions that get combined in a log linear way. So it's then this so-called log linear model where we have the functional form that we have a sum over different feature functions weighted by feature function model parameter, the lambda, and the exponential, and the whole thing gets renormalized. And if we use then that in the translation process, we obtain a very simple decision rule that we simply have the sum over the feature functions with a parameter value. And the important question now is, what are the relevant dependencies that we want to put into these feature functions that are the important dependencies for the machine translation process? And the best, right now, the best model in order to do statistical machine translation works on top of word alignment models and extracts a phrase alignment. So if we have here, for example, a German sentence and an English sentence, and here the word alignment, then the best working method right now extracts from this word alignment all possible phrase pairs that can be seen there in that sentence, and simply memoizes them and combines then these memoized phrase pairs in a clever way in order to translate new sentences. And so for that sentence, for example, we simply store all these different phrase pairs. Here we are only shown all these 2, 3, and 4 word phrases, but there are even more for longer or shorter phrases. And then these phrase pairs are then used to define various feature functions. So in the machine translation process, then we have we use these phrase pairs called alignment templates here in order to translate unseen sentences, and we define then a feature function which simply takes into account the probability of applying these phrase pairs, and that's in one feature function. Another feature function is the alignment, because in the translation process we might reorder these phrase pairs. So it's a feature function which models the probability of a certain alignment, which is then further structured. Or we want to select them specific words, so there is then the word selection feature function. In addition, there's a trigram model that is used, or the number of produced words is a feature function, number of produced phrases. And there are a set of 10 to 12 different feature functions, which are actually all very simple, that are taken into account. And if we do this, then we have the feature functions defined, and the next step then we need to train then for the feature functions the model parameters. That's then done, for example, using discriminative training by the first criterion, which is the standard maximum likelihood criterion, or by directly optimizing the new discriminative training method, directly optimizing the Bleu score or the NIST score on a development corpus. And so we have the feature functions, a very simple feature function, a training procedure, and then a search procedure. We simply apply dynamic programming beam search, restrict the possibility of reordering up to 10 words because to restrict the search space, and then if we apply that approach to machine translation, then we get typically very good results, at least compared to other systems. So that's the alignment template approach. The 2002 NIST machine translation evaluation for Chinese English obtained a score of 7.6, and in 2003, then at ISI, that system obtained a score of 9.0 and was significantly better than competing research systems or other commercial off-the-shelf systems that have been evaluated at NIST compared to this. And so one thing we could be happy, it seems to work good, but if you look at the system output, the system very often makes very stupid errors. And so the hope is that we now in this workshop can improve on top of this very good baseline and systematically reduce the number of stupid errors that the system makes. And here are some examples of the problems that the system has. So for example, in the first sentence, the resolution urged to the ceasefire and demands, and that's a translation that is produced by the system. But the correct translation and the better translation would be the resolution urges Israel and the Palestinians to ceasefire or end demands, and so on. And so obviously, very important content simply has been omitted in the translation process because the MT system hasn't been explicitly told that Israel and the Palestinians might be a very important piece of information that shouldn't be omitted. And so the idea is that during the workshop we tell the system that shouldn't be omitted. Or Indonesia that opposes the presence of foreign troops. Well, that's a minor problem. Or the next sentence, whether in brief, closing parent, opening parent, South Korea will be an high-ranking official to visit North Korea. So first, the parent problem is a very stupid one, and the better translation would be using brief South Korean high-ranking officials to visit North Korea in April. And so you see there are some very stupid mistakes, and the idea is, or the expectation is, the system doesn't know anything about syntax. All that it knows about syntax, it has been implicitly learned from what's in the data. And our hope is that we can explicitly tell him, for example, these are content words, they shouldn't be omitted in the translation. Or to tell him that there should be, if there's a source language, in the source language there's a verb in the sentence, and there should be in the target language also a verb in the sentence. So to refine then the existing, some more examples, to refine the existing machine translation system to add additional feature functions that explicitly look at syntactic platformness of the produced translation. So the more specific than the idea is that we have a statistical parser for the source and target language, and so far the feature functions which depended on the English sentence, the French sentence, the alignment and these alignment template sequences depend then in addition on a parse tree for source and target language, and we manually develop additional feature functions that look at then these properties which are described there in the parse tree. And the ideas for feature functions range from very simple feature functions to very complicated feature functions. So for example, the verb present in both sentences, then that might be a good thing. Or that the verb takes the same number of arguments. If in the Chinese sentence a verb with 3 arguments, then there shouldn't be only 2 in the English sentence. Or relationships between phrases should be transferred, so we have a dependency pass, then there are certain relationships between phrases, and these should be there in the Chinese sentence, and the same relationships ideally should be there in the English sentence. And then, so this is then already more complicated, and then we have, from Daniel Gilde, more sophisticated alignment models. Right now, the alignment model is a very simple alignment model that says, it prefers monotone translation. But we have already, which has been presented at ACL this year by Daniel Gilde, the tree alignment models for projecting trees or tree layers. So the plan basically is we start with doing an error analysis, feature hunting, where we then first go and detect systematic errors in the existing output, develop feature functions that we think, because of our knowledge, tries to avoid that error if we use it in the system, perform discriminative training of the model parameters, and then we see if this actually helps. If it helps, we are happy to keep it. If it doesn't help, we throw the feature away and search for a new feature. So it's a very engineering-based approach. And so that's the error analysis part. Then obviously the biggest part is developing new feature functions, which will take most time. Then discriminative training techniques. There are already various discriminative training techniques which are as tools available, and we are going simply to use. So for example, this directly optimizing blur scores, or the Yasmin tool for maximum entropy. And in addition, we might also investigate additional re-ranking techniques to support vector machines. And then for search, normal search would be then simply n-best rescoring, or we are also looking at minimum-based risk search with syntactically motivated loss functions. So what's already done so far? The framework we want to work on is the large data track Chinese image, so where I presented these numbers in the very beginning. It's a very nice task because we have huge amounts of training data, 150 million running words of training data, which is there, so there are a lot of different sources. We have a Chinese tree bank, which is used to train the Chinese parsers. We have development data, where we basically use the data that has been developed in the TIDES project for these evaluations. 170,000 words. We have test data, where we then constantly monitor our progress and measure the results. And then we have blind test data, where we then probably once a week, at the end of a week, we then see if we really improve our system and not only overfit on the test data. And then we have pre-computed 16,384 best list for the development and test corpora, produced by the baseline alignment template system. And so here, that should be blue in percent, 32, 45, 50. So if we have the one best, then right now the blue score is 32%. If we go at 1,000 best, the blue score is 45%. And if we go to a 16,000 best list, the blue score is 50%. So from that we can see more or less on what kind of improvements, if we restrict ourselves to that best list, what kind of improvements we at the very best case we can obtain. Obviously, we couldn't expect to really obtain the Oracle translation, so the 50% are not reachable, but in that range from 32 to 50%, the results can be in the end. And large parts of the data have been tagged, chunked, and parsed, so syntactically preprocessed, that we then can define our feature function on top of that data. We have ready-to-use tools, so syntax tools, English, Chinese, speech tagger, chunker, parser, conversion tools, discriminative training, maximum entropy training, maximum blue training, maximum list training, and feature functions, these tree-to-tree or tree-to-string alignment models. So how do we define success at the end of the workshop, or when are we really successful? So one thing what we want to measure is standard evaluation, which is right now performed at the TIDES project and from a lot of researchers, namely the blue and NIST scores. So if we achieve a significant improvement of blue and NIST, then we claim we are successful. So I put here only some numbers there, what kind of improvements we actually can expect. I don't know if we then will actually go beyond okay or not, but it's only, I think it's nice to have in advance some labels attached to this. So really over 6%, an improvement over 6% in the blue score, I think is really unrealistic. We would be better than humans then. So during the 6 weeks, we won't achieve that, I would expect. And but there is a potential problem there that these blue and NIST scores are probably not sensitive enough to measure the improvement in syntactic well-formed. So there has been a recent paper by Kenji Yamada where then this actually was the outcome, that humans like this translation much better, so they really got better scores if they asked humans to score the translations, but Bleu didn't show off that there was a real improvement. And that might be a problem because probably really we get better translation. The important thing is that humans like them better. But Bleu shows a 0% improvement. So in addition, we plan to make a human evaluation, which then judges the week 5 system. And if that is then significantly better than the initial system, then also we say, okay, that was successful. And the plan is to perform this at the Butler Hill group or the ADC, depending on various issues, where then all these 900 sentences which are in the test corpus are evaluated by humans. And obviously, the additional possibility for seeing that we have been successful is we make no progress at all, but we show that it's not possible to get progress using syntactic models. It's simply to learn everything off the data and to have more clever data-driven method, but all this parsing and then that stuff doesn't help at all. That might be, then we're also very successful. So the schedule of your week 1. The first thing to do is to get a one-click program for computing feature function, training of parameters on development corpus, computing the Bleu score on the test corpus, so that we have basically then people can write a 5-line Perl program to compute a feature function and then press a button and they get 5 hours, or ideally 1 hour later they get back the improvement. Does that give an improvement in Bleu or not? And then one of the first things also might be to integrate these tree-to-tree and tree-to-string alignment models, perform a contrastive error analysis from the initial system. So we already did this before, but to combine all the ideas that different people have, and plan then development of new feature functions. And then the rest of the schedule is very homogeneous, so week 2, 3, 4, 5, 6, error analysis, feature function development, and at the end of the week, we evaluate our progress on the blind test corpus. And at the end of week 5, we build a system for the subjective evaluation and ship it to the evaluators that they evaluated. So to the summary, the starting point of that is the best existing Chinese-English machine translation system. We want to build on top of that then syntactic feature functions to improve the results of that. We do that by performing a contrastive error analysis, so really looking what is wrong in the current existing machine translation system. Develop specific syntactic feature functions and try to fix these errors, and perform discriminative training of these feature function widths. Okay, thank you.
We're a little ahead of time, so if there are any questions, we schedule questions, anyone. Well, let me ask you, let me make a remark first of all that of course the achievement of showing that the syntax is useless is really a great achievement because it would free manpower.
Yeah.
Could you put on that those examples, where you had this thing with the Korean and all that? Yes. Pardon me?
When Japan freezes Russia.
Right. What's the reaction of Bleu to these errors? I mean, how does Bleu like it?
Some of them Bleu actually also likes very much because
That's
there's
what I was
only
thinking,
a word missing, so there might be a program or in the beginning, program in the end. And the changes there are quite minor for Bleu because also, as you see, then a lot of words condense US interference in its internal affairs. So in this sentence, a lot of words occur there. Also, there is only Ukraine missing, which is quite important word there. So that might be a real problem that Bleu.
Maybe you should explain what Bleu is. I don't think you said it here, and there might be a lot of people.
Yeah, so the Bleu metric then basically compares the produced translation with a set of reference translations. So for our corpora, it's always 4 references, and computes the precision of unigrams of the produced translation with respect to the references, the precision of bigrams, trigrams, and 4grams. And then these 4 precisions are multiplied, so the geometric average is computed, and then there is an additional penalty to avoid that people simply produce very short sentences to get a very high precision.
And the point, of course, is that there is not a unique way of translating. So they have 4 different ways of translating and hoping that somehow that gives a guidance to what a good translation might be. And
also that humans, so even if you have the 4 reference translation and producing a 5th one by a professional human translator, then the scores are typically 45% the blue score, so 0.45, not 1, as one would expect. So there is so much variation in these translations that...
so what would you have to go above the 50% mark? I mean, would you have to have trigrams and only trigrams that occur in the 4 translations? Your output translation, in order to get, well, you have as a limit 50%.
Yeah.
Okay, so to go above that limit of 50%, what would you have to have? That the trigrams in the proposed translation are all taken from the trigrams of the 4 prototype translations, or how?
So then I would expect that there would be, so if the language model would be really the reference translation, then the results should be even better. But I would expect that the limit is really then probably 55 to 60%, even having then much larger investors or word graphs.
To get better than 50, you have to improve the humans.
Right. So perhaps the way to answer the 4 reference translations that we have, if you took one of them and fed it, pretended that was your system output, it would have a blue score of 1.
Yeah.
So, but on the other hand, if you got another human being to produce yet another translation, you just said that that's only about 50%.
Yeah. You have to reduce the human variance.
So you have to somehow, figure out what this particular translator had in mind and write exactly that.
So just for those who don't know, I mean, the challenge is to have an automatic way of translating or evaluating. In speech recognition, it's easy. You know what the person said, you transcribe it, and you either produce it or you don't produce it, and we know what the errors are, etc. In translation, it's much more difficult. So IBM came up with a suggestion, and then which was improved, etc. Okay. Anyway, any other questions? Any questions whatsoever? No. All right. Well, thank you very much. And
I'm going to talk a little bit about the data sparsity problem and the approach that we would like to explore this summer for it. And I've only listed 3 of our team members. We have members from all over the world, but 3 of us are going to say a little bit about each aspect of this, so I put our names up there. So I want to talk first about what the problem is, what motivated this, and then what our approach to solving the problem is, how we're going to evaluate the project, and what expected outcomes we have, what we expect to lead to the workshop. There are a lot of NLP applications that we think have had some success, machine translation and information extraction, and they're kind of on the cutting edge of being made commercial in some sense. And we think, at least in information extraction, where all of us have worked, there's some tendencies to make fully portable information extraction systems and use techniques like unsupervised learning to customize them to particular domains. We hope that this effort will contribute to that, and I'll show you a little bit how that is. There are also efforts like the ACE project that are trying to do content extraction from text. And we see this as a kind of complementary effort to that. It's attacking the problem from a little different side. So we think of the problem this way. Whether you do statistical language modeling or you do more symbolic kind of language modeling, it's always important to have some representation of the world that you're trying to get information from. In the case of machine translation or language modeling, people have looked at trigrams and frequencies. And even in extraction, where people tend to be less statistical often, they still are trying to get word patterns from the text. And it seems no matter what type of data we try to gather, we always encounter new texts that have lots of phenomena we haven't encountered before. So that's what I describe as the data sparsity problem. The extraction community sort of moved to this kind of solution to the data sparsity problem. They tried to say, okay, can we find people and companies and positions in text, and can we mark them and kind of transform our training corpus? So it no longer looks how it used to look, but sentences look kind of like that. And this is actually from Ralph Grishman's slide the other day. So we have a transformation of the training corpus that says things like a person was appointed to a post of some company when we were looking for management successions, or a company named a person to a post. Now, patterns are then, we try to extract patterns from this. So they want to do things like find distinguishing patterns that appear in these texts that don't appear in other texts. So all of the patterns for extraction so far have been based on primarily on these entities that we started extracting, I suppose, about 1995 or something. People, locations, organizations, dates, times, currencies, and lots of systems throughout language processing have tried to improve their performance by having these. And I would say somewhat through that kind of technique. The question is, can we do more? And could we propose something for the 6 weeks that might contribute to that effort and augment what we already have and still help in this acquisition of pattern and representation of the population that we're trying to process? So the idea we had is, could we do something with the noun phrases in the text? Could we take the noun phrases and replace the whole noun phrase with the semantic category? So we have a sort of high-level transformation of the training corpus. So this is a sentence from some newswire. Astronauts aboard the Space Shuttle Endeavour were forced to dodge a derelict Air Force satellite flight. So the first noun phrase is astronauts, and we'd like to see it marked human. Space Shuttle Endeavour, we'd like to know it's a space vehicle. And a derelict Air Force satellite, we'd like to know it's a satellite, and Friday some sort of time reference. So could we improve what we had before by picking out some set of semantic categories and marking these? We hope that eventually a goal of this approach would be to be able to tell that those two sentences really had the same semantic content at some level. It's not a fine level, but it's at a very coarse level. It's at a level where we hope the data sparsity problem wouldn't be so intense. So that says the IRA bombed a family-owned shop in Belfast yesterday. And the next one is that FMLN set off a series of explosions in central Bogota. But even though the words are very different, they both involve organizations somehow attacking a location and some date. Now, we're not attempting to do this in the 6 weeks, but we see this as kind of the kind of transformation that we're contributing to. Okay. Now, the project was motivated by extraction, and that's why I talked about that. But we actually believe that it will help machine translation, so I'll say a little bit about that because that's going to be how our evaluation, part of our evaluation takes place. The ambiguity of words means that words often translate several ways. And so if we knew the semantic class of words in the source text, would that help us build a better model of translation. Well, knowing the semantic class is clearly helpful sometimes. I mean, you have cranes that are birds and cranes that are machines, and bats that are animals, and bats that you use for baseball and cricket, or you have a seal on a letter versus an animal. There are many cases where knowing the class would certainly help us to translate. But of course the question is, can we somehow show that the probability that if we translate crane to a certain, that's the Spanish grulla, is the probability that we translate crane to grulla, given that we know in the source text it's an animal, is that better than the probability that we translate crane to grulla? Or similarly, if we translate it to grua, when we know that it's a machine in the source text, do we get a a better probability than when we don't know it? And of course, I can probably convince you easily that we will be able to do that better. But the question is, are there enough of these in the text to actually have the effect of lowering the entropy? So that's what we'd like to try to measure. I'll just say a little bit about the language modeling part of MT, or just language modeling in general. In language modeling, we always want to know what's the probability of a word given its predecessors. That's a way to think of it. And since there are so many trigrams we've never seen before, it happens that if we just did that by straight counting, a lot of those probabilities are zero. And so we do something like smoothing to try to get estimates of a small amount that we can assign to the probabilities we haven't seen. So the question is, can we estimate those things in a better way if we know the classes? Could we, for example, estimate the probability of W3 given that we know the semantic class of the two preceding words? Or could we estimate the probability of the class given the two previous classes? So I hope that's a little motivation about why we're doing what we're doing and what we're attempting to do. Roberto's going to talk a little bit about methods, and Hamish is going to talk a little bit about the tools that we hope to contribute in the environment we're working in.
Thank you, Louise. If you can hear me, I would make no use of the microphone. The idea of semantic tagging is the idea of a task that has some similarity with the named entity tagging and with semantic disambiguation. And because we would like to employ some, let's say, unsupervised approach, we need also to machine learning approaches. And we would like to exploit, and we will, the similarities between this task and the previous substantial body of work in these three areas. As a named entity tagging, we would like to assign semantic categories to a structure, a noun phrase possibly, in a context. So we can see training material and we can develop and induce pattern matching rules. And there is some work in the induction of specialized grammars that are doing this task that are quite successful with the named entity tagging, like this phenomena that Luis was talking before. We would like also to combine these kind of approaches with the work that has been done in semantic disambiguation, where the use of several sources of evidence has been applied successfully at a finer level of distinction between senses. So the combination of external resources to the corpus, like machine-readable dictionaries or lexical knowledge bases, and the kind of training material that we will make available will be, of course, a strong principle. And then we would like to have possibly a domain and language-independent approach. So we want to make use of unsupervised techniques that generalize from training data. And we will also look at machine learning methods that will provide us with methods that are independent of the specific fragments of text that we were looking to, and will give us a model that can be measured and also applied and ported. For example, one of the trends in machine learning is to make the learning as much unsupervised as possible with active possibility by the machine learning device to look to new examples that are not included in the training material. This form of co-training will also be employed here. So, which are the sources of evidence that we will use? First of all, lexical information that provides with collocations, words that are priming some semantic characteristic of the target phenomenon. We will collect training material from this, and maybe Amish will add some details on the available training corpus. Then, from the training material and from general text, we'll also acquire distributional information about the context in which typical semantic phenomena are going to occur. Making use of robust parsing techniques, we will apply large-scale parsing methods to have also, as an additional source of evidence, kind of syntactic dependencies that help in some contexts, like subject, verb, object information, or the presence closer to the target noun phrases of adjectives that can be very meaningful. And then we will also apply the information stored in lexical knowledge bases, especially the internal structure of lexical networks, as a source of semantic information to evaluate the similarity between words. When you apply machine learning, you have a representation problem, so you need to decide which is the representation of your item. And so we will have a choice of deciding which representation and which space, so which is the matrix. And we will need to fix some metrics between context and between lexical items. Then we will experiment with several techniques, and these techniques will also be different according to the kind of methodological framework behind. Basically, we will employ example-based learning, ranging from decision trees to memory-based learning approaches. And the target, as Louise also mentioned, is to have a Bayesian kind of predictor. What is new in this kind of approach is the granularity, because we are just looking to a phenomena that is that have a coarser kind of granularity with respect to sense distinction that has been also undertaken in the past. And we think that focusing on that on those phenomena is useful, because we can obtain with current technology a good level of performances that are very helpful in the application that Luis was mentioning. Then we will integrate machine learning methods. That is, for example, we will try to integrate the symbolic induction of specialized grammars with quantitative models that comes from probabilistic information. And then we will also apply co-training, because we will make use of the large annotated data set that we will start with, but by applying active learning techniques, we will try to sampling the unannotated material. And this is a very important kind of original feature. I think that measurement is quite important now, and Amish can add something.
So I'll finish off our talk by talking about two things. First is how we measure what we're doing in a project, how we know when we've succeeded or failed to succeed. Maybe we can also take semantic tagging off the agenda along with syntax-based machine translation and really reduce the scope of the field. And then after I talk about that, I'll talk about how we plan to try and maximize the impact and the longevity and the usefulness of the outputs of the project beyond these 6 weeks. How do we know what we're doing? We're running the project relative to a gold standard, a hand-annotated set of data. It's taken from the BNC, the British National Corpus, which is a 100 million words balanced corpus, so it's fairly diverse. We've managed to annotate 1 million words over the last few weeks, of which a little under 500,000 contains 500,000 categorized noun phrases. I'm not sure that we mentioned it in the early part of the talk, but we're starting the problem by addressing noun phrases, so that's what's important for us, at least at the beginning. We can use the corpus for the intrinsic evaluation of the data. We've got two ways of evaluating whether we're succeeding or not. One is kind of internal, intrinsic component level evaluation, and then we have standard measures of things like precision and recall and false positives of what the machine is generating in relation to the annotated data. And then, as Louise mentioned earlier on, we're interested in trying to see whether this approach to reducing data sparsity can also reduce perplexity and lexical choice for machine translation and make the translation task a little bit easier. The baseline, which we're hoping to jump somewhere above, is if we just assign the most common category all the time, then we'll score something like 33%. So we're hoping for at least 34. Just to give you some idea of the ambiguity levels in the annotated corpus, this is the distribution of noun phrases to numbers of categories. This says census, it should say categories. Around 75% of the noun phrases have between 1 and 3 categories. Then it tails off. We've got about another 20% or so that have between 4 and 7 categories, and some that have even more than this. And in total, the interim total is 450,000. We were still working on this over the weekend back in Sheffield, so there's a few more to come yet. Okay, that's evaluation. Finally, I wanted to talk a little bit about a kind of stylistic point, a kind of meta issue, if you like, in how we're doing the work and how we're trying to make it useful for other people in our community after these 6 weeks. So the project really has 3 outputs. 2 we've kind of talked about already. We're producing a new resource. We have this hand-annotated version already. By the end of the 6 weeks, we'll have automatically annotated the whole resource. Of course, it won't be as accurate as the hand annotation, but we'll have experimental data, experimental evidence about the resource that says how accurate the final results are in the machine annotated version, and also how accurate various methods are that we've employed to do the annotation. So those are 2 fairly standard results from this kind of process. We also want to make available some of the components that we develop for implementing these methods as software tools that other people can potentially take up and use and tailor for doing this and similar tasks in the future. And one of the ways that we make those tools a little bit more general and a little bit more generally useful than they might otherwise be is to use a system called GATE, General Architecture for Text Engineering. What is this thing? It's really 3 things, a combination of 3 different things. One is that it's an architecture, and by architecture I mean a kind of high-level picture, a macro-level organizational structure for how language processing systems might typically fit together and be organized. Secondly, it's a framework. The framework is just a posh name for a class library, an object-oriented class library that implements the architecture and provides services for embedding in hopefully lots of diverse other software applications and experiments. Thirdly, on top of the framework is built a development environment, a whole bunch of graphical tools that helps people like us when we're developing these kinds of systems. And it comes bundled with a set of language analysis tools that have a long history in doing various sorts of extraction. There's a bunch of free components. There's an increasing number of wrappers for other people's components as people take up the system and integrate their stuff and so on. various tools for things like evaluation, data visualization, editing, dealing with multilingual data, assistance of data, and so on and so forth. And it's free software, it's under the Lesser Canoe public license, so you can do pretty much what you like with it. Where did this come from and what's the kind of relevance in the context? As the person who spoke second earlier on, I've forgotten his name now, but he referred to this increasing trend towards multi-site collaborative projects in science and engineering over the last decade or so. And this was one of the realizations that a number of different researchers had in the early and mid-90s. Importantly, the Tipster program, which I guess a bunch of people here are familiar with, had this kind of realization, and also started thinking about the role of engineering in producing scalable and reusable and portable language technology systems as these things moved out of the laboratory into the marketplace and moved from small-scale experiments to large-scale experiments. This also, this kind of trend created an increasing need to support large data sets, multiple media, multiple languages, formats and locations. And people were really starting to think how they could lower the cost of creating new language processing components in this changing world. And also to promote, one of the strands of the work was to promote quantitative evaluation, to promote measurement in a field which has sometimes been rather bad at saying exactly, precisely how well we're doing in a kind of quantitative fashion. So this was a matter of increasing interest over the years. And in Sheffield we began developing, sometimes in collaboration with the Tipster folks, in fact, this thing called Gate. And we released an initial version in '96. A little while ago we released a rewritten version. We're about to go into a new development cycle soon. What do we think this can contribute? This is my last slide. What do we think this can contribute in the project? Three things we think it can do for us, related to productivity, quantification, and repeatability of our results. So we're going to reuse some baseline components. One of the things the system does is make it easier to reuse work from the past, easier to install and so on. We have this development environment that I talked about. Maybe it's something like MATLAB for human language technology developers. That's rather too grand a claim, in fact, because we don't have the resources behind systems like that. But that's the kind of general area that we're in. It reduces the integration overhead. There are standard interfaces for components to talk to each other and to represent data and so on. So it reduces the amount of time it takes you to plug things together. And it takes care of things like data consistency and visualization and so on. Those are all things that we hope will increase our productivity in doing work. Quantification, it has tool support, it has automated support for metrics generation. It has some graphical tools for saying how well a system's doing and for seeing exactly what the differences are between what the machine produces and what the human being has produced in some nice graphical forms. And it has a regression test tool, so you can run your tests over the corpus nightly or as often as you like and see if what you've done today broke what you were doing yesterday or something. Repeatability. It's sometimes hard. Well, there's always an overhead in repeating experiments at different sites. But it's kind of important because until somebody's repeated your experiment, you're not really sure that there weren't some site-specific effects that were skewing the results and so on. So we hope that by providing open source tools and by providing a kind of underlying system that is supported, that is maintained, that is documented, we're contributing to make it easier to repeat the results of experiments in different places. And so we support different platforms. We've done a lot of effort. We've made a lot of effort in making it easy to install and so on. And now we have thousands of users, hundreds of sites around the world. And finally, one of the things that it does for you is it will load components over the net. So you don't even necessarily have to have all your components installed in one place. Mobile code if you're working in Java. If you're working in other languages, then we have to start thinking about web services. So this is just to finish up by saying one of the things that we hope will contribute to making the results from our workshop usable for other people in the future. I took too much time.
Time for questions.
Yes.
Did I want to first talk about the selecting the granularity for the semantic categories, the source, and determining the right granularity? I also missed the leap from the non-graphical or word census distinctions to the semantic categories. You're looking for a word net or what?
You want to say?
We didn't want to take a lot of time defining semantic categories in a 6-week project. And so the proposal was to use some subset of the Longman Dictionary categories, which were 34, and to just see what effect that would have. We've reduced that set by trying to do mapping with WordNet, trying to pick some semantic categories that we hope we can have some accuracy on. So there are things, we divided the world into concrete and abstract, so that abstract things like happiness and ideas and so forth are just marked abstract, because that's a very hard world to try to capture. And we'll try to mark those things just abstract. The concrete things are marked as to whether they're animate or not animate, and if they're not animate, whether they're movable or not movable solids or liquids or gas. So it's very basic properties. The plus side we saw is that Longman's coded a whole dictionary using those as selection restrictions. So all adjectives say the kind of noun they would like to appear with in terms of those. And all verbs are coded with the kind of subject and object. So we're hoping that may help us. We just thought it was a reasonable base set of categories, and we thought pardon me?
So what's the size of the final set?
The size of the final set is 9 that we want to do. We prepared training data that actually has other information, but I don't know how much of it we'll get to use. We also included in the training data all the topic markings from the dictionary. So when the annotators selected the class, if there was a topic marking with that class, it is put into the data. With some richer data there that we can make use of it too. Like, for example, if you see something like bracelet, it says it's a movable solid, but it also is marked jewelry. So if the annotator chose that category, it's in the corpus, and we have that marked.
Check.
Go back to 17.
Can I just add a word on that?
Yeah.
One of the intuitions behind the approach was to restrict the problem considerably from the general problem of word sense disambiguation, to really cut down the amount of categories. And we thought that by doing this, we hope to get a higher level of performance. And because the general problem of word sensitive disambiguation is so hard that the performance levels tend to be very low, we figure by restricting the task, we can push the performance up to levels at which it becomes more useful for the applications that we want to try and
Check. Could you see back to slide 17? So what is the zero category?
Good question. I think it's just numbered wrongly. It should be numbered from 1. That means there's 1. Those are non-ambiguous. There's no ambiguity.
It's one on the chart.
There's 1 on the chart.
So that's 23%.
Okay.
That was an observant question.
These are different semantic categories.
Answer your
Pardon
question.
me?
These are different semantic categories.
It's how many
These are
semantic
just-
categories?
These are how many?
Word sensitive.
How many categories the noun phrase appears in?
So, I had a question about the code training, the corrected code training stuff. So, there have been a couple of papers on corrected code training. And the one by Claire Hardy and a student actually showed that it did work for a certain application. And recently, the participants from last year's workshop, we actually made some modifications to corrected code training to actually get it to work for parsing. So it's very tricky actually to get it to work. It turns out it's not an easy way.
Yeah.
So do you know if there's something about the application that would actually pay off in this setting?
Yeah. Okay. Here the application is basically, let me understand your point. The application is possibly the kind of semantic class we are targeting. So there is some specificity to each phenomenon. For example, animal can rely on phenomena in text that are different from other categories. So this is something that the co-training should take into account. And then there are other issues, because we will have training material with kind of lexical information, but also syntactic information. And so there is a form of co-training, because you have several levels, linguistic levels that provide evidence. Then there is another dimension that is given by the machine-readable dictionaries, because we are using also information coming from WordNet. So the idea of using long kind of classes will be, in some sense, integrating and will compete in a co-training scenario with the information that is coming from WordNet. Just for giving you an example, if you have typical nouns that appear in a given subject with dependency with a verb, you can cluster them. You have information from the dictionaries about their trend, their semantic attitude to take one class rather than another. So there is a dimension that is not typical of the target phenomena, but is typical of the resource that we would like to employ. So we have a multi-dimensional co-training effect to explore that will provide us a number of interesting issues to model in terms of a co-training, because we can think to a purely empirical combination. Co-training gives us a formal framework to understand better the kind of reciprocal contribution, and this is a topic that we would like to explore.
One more question, if there is. No? Okay, thank you very much. George next, George Foster.
So I'm going to be describing our workshop. Is this working?
Yes, it is.
Which is on confidence estimation for statistical machine translation. If you look in your agenda, it's labeled as confidence estimation for NLP, but it's somewhat more narrowly construed than that, although we hope to be able to derive conclusions that will be broadly applicable to NLP. So here's our team. We're officially a half team, which means we have two academic senior researchers, me and Simone Ganderberg, my co-organizer. We have Cyril Good from Xerox in France, and Lydia Magnu from IBM, who will be joining us for 2 weeks. And then 3 graduate students, Eric Fitzgerald from Johns Hopkins, Alberto Sanchez from University Politecnica de Valencia in Spain, and Nicola Oething from RWTH in Germany, and then John Blatz and Alex Kulish are undergrads. Okay, so I'm going to just first talk about, give you a bit of background on confidence estimation in general, and then get to the tasks that we plan for the workshop. So confidence estimation is just the attempt to determine whether the output from some NLP system is correct or not in a given context. And as you can imagine, this is useful for practical applications of NLP systems which tend to be imperfect. So if you can't get the right answer, it's helpful to at least know that you're wrong.
Almost all of the previous work in confidence estimation is in the field of speech recognition, which is pretty much arguably the most mature NLP technology. And there's very little work in confidence estimation outside speech recognition. So this is really the motivation for the workshop. Apply these confidence estimation techniques to another area of NLP and see how we do and see if we can draw some general conclusions about how broadly these techniques can be applied. Okay, so just to be a little more precise about confidence estimation, the goal is to characterize the behavior of some base NLP system that basically takes an input X and computes an output Y. And there are two versions of this. A weak version where all you have to do is say yes or no. So a common way to do this is to calculate some kind of score that's a function of your input, your output, and obviously the base NLP system. And if the score is above a threshold, say yes, otherwise say no. And there's also a strong version where you're interested in not just saying yes or no, but quantifying the confidence you have in your answer, and the appropriate language for doing that is probabilities. So in this case, your scoring function is actually an estimate of the conditional probability that you'll get the right answer. So strong confidence estimation tends to be more useful than the weak version. For one example, if you have an NLP system, an NLP application that just makes a binary decision, like information retrieval, where you're interested in making binary relevance decisions on a text given a query, the weak form of confidence estimation doesn't really do anything different from the base NLP system. On the other hand, if you know probabilities of pertinence, this can be useful. It can give you a guarantee on your precision if you have confidence in your confidence estimation. Okay, so there are many applications for confidence estimation techniques. The most obvious is probably improved user interaction with the NLP system. So the idea is you want to maximize the amount of work that's done by the NLP system and minimize the amount of work that the human has to do. So for example, in a speech recognition dialogue system, where the system can return to the user and prompt, if it hasn't understood, can ask for a clarification, ask the user to repeat what they've just said. You don't want to do this indiscriminately. You want to do this when the system genuinely hasn't understood and not just every time. And you do want to do it in cases where the system hasn't understood. Another application is post-editing for machine translation. If you have a translator who's going along and whose job is to turn MT output into acceptable translations, it's helpful to be able to focus them on the parts of the translation that are likely to be wrong. Another application is bootstrapping learning, where you have an NLP system going through a bunch of input examples and producing outputs and labeling those outputs, labeling a subset of those outputs as potentially incorrect. And you have a human annotator going through and correcting only those examples, and then you have the NLP system, a statistical NLP system, we presume, learning again from these examples, and then you can repeat this process iteratively. And you can show that if you have a fixed amount of human annotation effort to spend, that's a more effective way of doing it than just taking a block of text and having a human go through and label that. Another application for confidence estimation is model combination. So typically when you combine different approaches in NLP, the results are better than any of the single approaches you're combining. So the strong version of confidence estimation, where you're estimating probabilities, gives you a uniform framework for combining output for different systems. Even ones that are non-probabilistic, for which you wouldn't have any kind of natural score that you could use to combine. So the idea here is you just do a confidence estimation in each system's answer, and you pick the answer in which you have a highest confidence. And finally, there's the idea of recombination, which is if you have an NLP problem like machine translation, where you're producing sequence outputs, and you're capable of generating an n-best list of good answers, you might be able to, using confidence estimates on parts of these output sequences, recombine different hypotheses to create a new answer that's not necessarily in the n best list that you started with, that might be better than any of the hypotheses in the list. So this idea works for speech recognition. This is related to the idea of applying confidence estimates for search, where you want to be, you're interested in expanding search partial hypotheses during search. And in order to know which ones are interesting, you want to make confidence estimates and expand the ones that are genuinely have high probability of being right. Okay, so there are really two main approaches to confidence estimation. The first is just to use scores or probabilities that you derive directly from the base NLP system. This is a simple method. It's often a very effective method. What you need to do if you're doing this is particularly if you have a statistical system, you want to make sure that you've done proper smoothing and do careful estimates of posterior probabilities. Another technique is to use a separate layer, a separate confidence estimation layer on top of your base NLP system. And the idea here is to use machine learning techniques to learn the performance of your base system on a corpus that's distinct from the one on which it was trained. So you learn when it's likely to make errors and when it's likely to be right. This approach is really qualitatively different from the first approach, but it has some advantages. It has some modularity advantages, essentially. So it lets you separate out the problems of picking the best solution, which is the base NLP system's job, from the problem of determining whether or not it's correct. And you can imagine that different features can be applicable to these problems. For instance, in MT, something that correlates really well with the number of errors an MT system is going to make is the length, just the length of the source sense. So that's a very useful feature for a confidence estimation layer, but it's not very useful for MT itself. Just the length of the source sense doesn't tell you very much about what the translation should be. A couple other advantages. It may be possible to reuse confidence estimation techniques for different base NLP systems. So if you create a confidence estimation layer and you have certain features, those features may be applicable to different NLP problems. And a final advantage is for adapting base NLP systems to new domains. Statistical NLP systems are notoriously specific to the domain on which they're trained. And it may be very hard to train them for a new domain, particularly if you don't have annotated training data available for it. So a quick and dirty way of adapting it to a new domain is just to adapt the confidence estimation layer, which is smaller. Okay, so an overview of what we planned for the workshop. The base NLP system that we're using is Franzok's statistical alignment, the template statistical MT system. We're also hoping to get access to Carnegie Mellon's statistical MT system. And the data we're using are n-best lists for the NIST evaluation program, as Franz described in his presentation. So we're really just piggybacking on the statistical MT group for our data. So what we want to do with this is estimate various probabilities of correctness from the data, evaluate them using abstract measures that let us describe how good confidence estimation is in the abstract, and also within some applications. We want to assess the value of different features for this task. So we can look at features that are intrinsic to the difficulty of that sort of capture the intrinsic difficulty of the source sentence. Other features that are translation specific. How likely is this source sentence and this target sentence to be a valid translation pair? And finally, features that depend on the base statistical MT system. We also want to compare different machine learning methods and configurations. So we're going to start with neural nets because they give a very easy way of estimating the kind of conditional probabilities that we're interested in. We'd also like to experiment with SVMs. Of course, we'll also compare what we're doing with confidence estimates derived from just the base statistical MT system, and we'll look at other things like classification versus regression. So some of the challenges we face are sparse but large data. What I mean by this is we have only a couple thousand source sentences, which is a very small amount, which covers a very small amount of the possible source sentences that are out there. But for each source sentence, we have approximately 20,000 possible hypothesized translations. So this makes a very large amount of data, particularly in machine learning terms. So it limits the machine learning approaches that are applicable. Another challenge is that the performance of the base statistical MT system is low. I mean, it's relatively good, but in absolute terms, it's low. I mean, there are not many completely correct translations. So we have few positive examples from which to learn. And then finally, just this issue of evaluation in general for machine translation. If you compare a possible translation with a reference translation and you get an exact match, you know you're right. But if you don't get an exact match, you don't know that you're wrong. So there's a degree of uncertainty in our when we're trying to tag our translation hypotheses as correct and wrong. So the first and the main task that we're going to be tackling is sentence level confidence estimation. So we're given a source sentence and a possible translation. We just want to say whether that's correct or not. The big problem we have here is, as I mentioned before, correctly translated sentences are rare. So it's hard for us to learn what's right or not. Our solution to this is to move the goalposts and define correctness as being not a complete match to one of the reference translations, but an error measured below a certain threshold. So we can play with the threshold. So this leads to two different machine learning approaches. We can use regression to learn the error function directly and then apply a threshold afterwards to determine correctness or not. Or we can, right off the bat, tag our training corpus, tag examples in our training corpus as correct or not, depending on whether or not they are under the error threshold, and then treat it as a classification problem. So we want to test our results on this on 4 applications. First of all, model combination. We'd like to compare the alignment template, combine the alignment template results with results from the Carnegie Mellon statistical MT system. So we'll have an best list from both and compare them. We'd also like to do a filtering for post-editing scenarios. So if you assume that some degree of error is tolerable in your MT output, but for sentences having above that level of error, you want to send them to a human translator. You want to use confidence estimation for doing this sort of filtering and perhaps assign some costs. Say, what does it cost to have a human translator revise a sentence that has this level of errors in it? And we can do a little simulation where we can estimate the reduction in cost that we achieve through the use of confidence estimation. Another application is bootstrapping learning in a slightly different definition from the one I described earlier. The idea here is to train the statistical MT system on a training corpus which we assume contains some noise. Use confidence estimation to go over the training corpus again and filter out pairs that have low confidence on the hypothesis that these are just noisy pairs. This is pertinent, particularly if you're trying to learn an MT system from data obtained from the web, because it tends to be very noisy. And the final application is re-ranking. So if we have confidence estimation scores, we can re-rank hypotheses in the M-best lists. This is exactly what the statistical MT system, statistical MT group are going to be doing. Our sort of aim is different, so we can't expect to do better than they do in this task, but we'll sort of be an interesting baseline to compare their results to. They better beat us. The other main task is sub-sentence confidence estimation. And the idea here is to estimate correctness probabilities for parts of translations. So words and low-order n-grams. And we can condition these on position. So what's the probability of a word, this word occurring in this particular position in a translation? On the alignment, what's the probability of this word being the translation of this particular part of the source text, or on nothing at all. So there are some problems with this. The first is that we might not observe an n-gram many times in the n-best list. So we're going to tag it as correct or not, depending on whether we get an exact match in one of the reference translations. But one of the main features we use for trying to predict whether or not it's going to be correct is the number of times, or the probabilities that are assigned to it in an n-best list. And particularly for longer n-grams, we may not have any examples. So the idea to get around this is to look for equivalence classes on n-grams. The other problem, this is not a problem for estimating probabilities, this is a problem for what do we do with these. If you know the probability of some word occurring in empty output in the abstract, independent of context, what can you do with it? Well, here's an example of one thing you can do with it. Suppose that we have these top 4 letter sequences represent 4 possible correct translations for some input. If we just look at the individual probabilities of the words in each position, so what's the probability that what's the probability of words in the first position, the word that has the highest probability of B. Similarly for the second, and the same for the third. So if we pick words individually like this, the sequence that we would consider most likely is BBB, but that's not a correct translation. So this is an idea that works in situations like speech and part of speech tagging where you have one correct answer. But we can't really expect it to work in statistical entropy. Not as is. So we're going to look at 2 possible applications for these kind of sub-sentence confidence estimates. One is identify error regions for post-editing. So in general, it's hard to say that some part of a translation is correct and another part is correct because they may not be simultaneously correct. They may not be coherent. But we can say that some region of the translation is wrong. Because if it's wrong in any possible reference translation. So we can identify an error region. And the idea is a translator going over this might have his or her attention directed to this error region and could correct it. A really intriguing idea is hypothesis recombination. So we would like to be able to go through and make confidence estimates on words and n-grams, and based on these, splice together parts of the n-best list to create a better hypothesis than appears anywhere in the n-best list. But this is, for the reason I just mentioned, appears to be quite a difficult problem. So this is an open research question we'd like to tackle during the workshop. And a final application is confidence estimation for word alignment. So given an aligned source and target sentence pair, what are the probabilities of correctness on each of those word alignments? And this has all kinds of applications, among which would be training an MT system. A problem we have in the data that's available to us now is that we don't have reference alignments, but it may be possible to hand tag a small set of reference alignments. So that's... Thanks.
Any question? I have a question. Is your slide still on?
Can you put it up?
Could you put up the example slide? You know, the one that we put up already once.
Adapter.
So what would confidence do here? I mean, here we have, for instance, the resolution urged, etc., and the resolution urged Israel, etc. So,
Okay, so, right, what we would hope to do is distinguish between these various poor translations based on, for instance, the word error rate, which we would assume correlates with, say, the cost to transform this into a proper translation.
so on the first example, you would mark the as correct, as high.
Okay,
what would we
Right.
mark here? I mean,
No, I was talking about at the sentence level.
well, then everything is crummy, so
Everything's
no
crummy,
confidence whatsoever.
No, no, but
So-
some things are crummier than others.
Okay, tell me which is crummier than some other. I mean, I have just no idea what we would do with something like
Well, something that's crummier than others is something that leaves out a keyword. Where was the?
Well, Israel and Palestinians.
That's
So
crummier
that's
than
the
the rest.
crummiest of all. So,
Right. So, okay, I mean,
well, George, I mean, you understand my question. I'm completely lost as to how we would order this.
Are you using it as the reference translation when you do the...
yes.
No, but of course he has to put on confidence without having seen the reference translation.
But there's a training phase and then
No, I know, but I'm wondering, in the final analysis, when somebody kicks out the sentence, the resolution urged the two with ceasefire and demands.
Okay, so I mean, at the sentence level, you have to believe that there are better and worse wrong translations, right? Because most
I understand that, so, but I mean, how would I believe that?
Well, I mean, we can test it. We're gonna. What we can
Well,
do-
is this a semantic question that I can't understand at all what the first sentence is telling us? But maybe the second sentence, I'm talking about the Indonesia, sort of.
I think this is the problem of machine translation and evaluation in general, right? We're not at the stage where we can say. I mean, we're at the stage where we can measure things like word error rate and n-gram precision, but not weight those n-grams based on which of them are semantically valid. So,
Yeah, let me hazard a guess on how this might work. So one of the features, for example, in the confidence estimation might be how many words in the source sentence got dropped, because in our template model there is this notion of something just disappearing. And perhaps this sentence will show that there was something in the Chinese word sentence, some 3 or 4 words, which simply don't appear, and that might be a bad sign. So we may worry about the first answer based on that. So I don't have a good sense yet of what the features will be, but there clearly ought to be features which look at the source sentence together with the target.
But that wouldn't necessarily increase your use cost.
I mean, for instance, I suppose I could look at the first sentence and say that grammatically it makes, it's not a sentence. So then we'd give it a low confidence.
Well, if there was such a feature.
right.
Well, why wouldn't there be? I mean, actually, that's one of the simplest ones, because we do know grammars and we know that,
all I'm saying is
that the two is not a bigram which can occur in English language.
No, all I'm saying is I'm not imposing a feature on them. I'm hoping that it's some such feature.
But your question is about the application, right? Not the methods that we're using.
My question is that in your situation, in fact, in the test situation, you get the string of English words. You don't get in the test situation you get the string of English words and you get the string of quote source words.
Right.
And now you've got to say something about how confident you are either about the whole string.
Right.
Well, with probability 1, you're not confident at all. So that's number one. So you have to somehow be able to segment this in telling us that in parts of it you have confidence. And that's why I asked him to put on these examples, because I don't know how I would segment it.
The segmentation problem is a lot harder. I agree. I mean, I think this thing is fairly clearly defined at the sentence level, and it's obvious that there could be some applications like model combination and so forth. when we start to look at parts of sentence and say, this is correct and this is wrong, I agree, it's ill-defined. It's hard to say, you know, if you want to sort of highlight this into right and wrong regions, what does that mean? It's not, it's something that we're...
Then what are we going to try to do?
Well, what we're going to try to do to start off with is, what's well defined is the probability that a word or an n-gram is right or wrong. Will appear in the reference translation. That we can do, and that we can measure in the abstract. The problem is, how do we apply that? How do we use that information? That we have to work out. I mean, one possibility is to say, well, here's a really bad wrong region, as I indicated. And another possibility is to try to splice together parts of an n-best list. There are big problems with that, but there have been similar approaches in speech recognition. This is one thing that Lydia Mangu will be looking at when she comes, because she has been involved in this in speech recognition. See if these techniques can be adapted some way. So,
Erin had a question.
No,
Go ahead. Erin had
first, go ahead.
for a while.
I was just going to say, well, I was understanding what you were asking maybe as being, how do you look at that first sentence and determine automatically that it has low confidence? And I was going to suggest that one thing is if you have 30,000, like a 30,000 n-best, that if a lot of the lower translations have content words like Israel and the Palestinians, and then what you had at the top was missing that content, then you would mark it as something maybe was missing, and then a human translator could go back and go back up and retranslate it. So I was just...
But of course, in a situation that you're describing, France's system would surely not omit Israel and Palestine. So actually, if there was Israel and Palestine everywhere, any machine translation system would stick that in.
Well, it's not clear. Anyway, I was going to make exactly the same point.
Simona was going to say something too. So.
Well, I guess we were questioning the usability of having a confidence score at the sentence level. Why do we need this? Can we expect to have a confidence score that says us something about that is actually useful? And I would say that statistical machine translation is based on putting a score on a sequence of words. So statistical machine translation does exactly that. It looks in a search space and it tries to pick sequences of words by assigning them probability scores, right? So if we can improve the discriminability of these scores, if we are just able to improve not the ordering, but just tagging whether it's correct or not, like the possibility of rejecting false or wrong translations or parts of translations, we already gained. So this is the base, I guess that's the basis. So how would we score? I was looking, for instance, at the second example, Indonesia, that opposed the presence of foreign troops, where if we were able to tag Indonesia as very, very confident, and that opposed the presence as low confidence, but foreign troops as high confidence, then a post-editing exercise would just look at the middle part that is not very accurate, right? So
I suppose if you were going to do that, then for some information extraction task, you would gain something because you would know that that sentence has to do something with foreign troops, and then if anybody is interested in foreign troops, he better learn the Chinese to find out what the hell it's talking about. But at least it would look at sentences that would not have foreign troops in it.
yes, or for instance, or for filtering, or if you're looking at an interactive machine translation application where you type translation, and as you go, the system might propose you translations like the continuation of what you just typed. So you might want to be able to filter out translations that have a very low confidence in order not to annoy the translator continuously with wrong translations, and just propose the good ones. So there, discriminability is very important. So this is where we can improve, I guess.
Bill, I'll come back to you. It's just that Bill has something to say.
that
I just wanted to observe that, relative to speech recognition, in speech when we do these combination techniques, we don't have to worry about movement. And the alignment problem, there is no alignment. There's not really much of an alignment problem. I mean, the VVV example you gave is a good one. That could come up in speech, but it doesn't because the acoustic evidence for it isn't there. But in some sense, you're undoing a problem that you might be avoiding if you work with lattices directly rather than with n-vestlets derived from this. Because the lattices will contain the alignments, maybe they would contain the information more directly. Or in any event, you could find like just lattice posteriors over segments.
We'll be looking at word grass and word lattices in this project.
And
we also have all the alignments, we have all the end alternatives, they are sort of anchored to the source translation
because... But then that answers Fred's question, because you can get posterior distributions over phrases within the sentence.
Right.
Yeah, I think that it's clear that we can estimate those. Maybe the question is, what do we do once we know those probabilities? How are they usable? Because if we just estimate the probability of an n-gram occurring, this particular n-gram occurring in a translation, doesn't say anything about whether it's correct in this particular translation. So you could have two right, a right first half and a right second half of a translation combined. They just don't go together.
Well, I mean, I don't want to belabor it too much. It occurs to me that if you have a phrase and there is an adjective missing, and the same phrase where the adjective is wrong, but there is an adjective, I have no feeling for whether I'd like to have more confidence in the one where it is missing than the one where the adjective is there but it's wrong. So that's something that you will have to define, right?
Yep.
Okay, Sanjeev, and then we'll conclude.
It was just a remark that the example that you had up there, perhaps what was misleading or confusing there is that what was stated as better was probably the reference translation. Is that right?
Yeah, of course.
Because if it had been out there, if you had put in something else deeper in the best list,
yes,
then perhaps the problem is easier stated. I want a technique that will pick the second one out of the best list rather than the first one. And that goes back to Bill's remark, that there might be evidence in the rest of the hypotheses in the lattice to support what is deeper in the list than what's on top.
But actually, so the second one, I think, was a reference, and in addition, it was also among the 16,000.
Oh, it wasn't. So that was
also
actually in the...
That can be selected.
There was a candidate in there. In fact, so the answer is the translation system did in fact leave out a 0 and
All right. Any other questions? I want to say just what we omitted in the introduction and in its schedule. There will also be a steering committee meeting today.
Yes, it wasn't the schedule. We just haven't announced the time.
Oh, it's going to be at 4 o'clock in the conference room. And members are the three team leaders plus Bill, Sanjeev, and myself. Okay, there is a break now, unless anybody has a question. I don't know whether we really want to take 25 minutes of break. That seems a little exaggerated. So, I give you Laura Graham, right? Who's going to tell you what to do and what not to do. Listen carefully.
I'm not going to try and give you that many rules and regulations. I would like to welcome everyone again. Most of you I've already seen for the past 2 weeks, but to the senior people who have just arrived, welcome. First, I want to introduce you to some of the other people who have been greatly responsible for helping put everything together. As Jack Godfrey mentioned earlier, a lot of work goes into the preparations and planning and getting everybody here for the workshop. And the people who I'm going to introduce you to have been invaluable in making all of these things happen. The first person is Sue Porterfield. She's over here. Most of you have communicated with her by email. And she has handled quite many of the arrangements for you and will continue to be processing some information and reimbursements and stuff like that for you. The other two people are Chris Gainey and Charles Choi, who are over here. They're our student workers. They have also been heavily involved in the preparations and are responsible for many things, including the welcome bags that you received at your rooms, either at the Broadview or the Colonnade. And the last person I'll introduce you to is Brian Sloan. He's responsible for all the information that's up on the webpage, and he will be around pretty much every day during the week to keep the webpage updated. So if you have any information that you need assistance with related to the webpage, you can contact Brian directly, or Sue or myself, and we can help you with that. As I mentioned, everybody should have received a welcome bag at your room, either at the Colonnade or the Broadview, and it should have contained a blue folder like this that has lots of information about Baltimore, a little bit of information about the campus, a campus map, and some other items that will be crucial to you getting travel reimbursements and also your per diem and stipend checks. First, you should have a brown envelope, I think with your name on it. If you could please put all of your travel receipts in here. There's also a form in here that needs to be filled out that will ask you to detail what each of the receipts is for. Once you've completed that, if you turn that into Sue Porterfield, she'll process the request for reimbursement. The checks will be sent here, and then once we receive them, we'll track you down and hand them out to you. One of the other things that's in here is a form to get an ID card for campus, and this will allow you access to the library and also to the athletic center. It looks like this. The only thing that you need to do really is fill in your name and your social security number, and you can also either give that back to Sue or myself or to Charles or Chris, and we'll get those processed. It's taking maybe 3 or 4 days, maybe a week to get the ID cards, and once we do get them, we'll also hand those out to you. As I mentioned, that will allow you access to the library, the main library on campus. You will also be allowed to check books out from the library. If you do, just please make sure that they're returned to the library before you leave. If you can't get up there before you leave, you can also give the books to Charles or Chris, and we'll make sure that they get back to the library. For some of you who are not U.S. citizens, you may also have additional forms in your folders that need to be filled out and taken to the international office. If you haven't already checked in, most of you, the students who have already been here for a couple of weeks, have checked in. If you haven't checked in, if you could complete those forms, and then there are some items that you have, your passport, your visa, a couple of things that we need to make photocopies of, and then Chris or Charles will arrange a couple of times today and tomorrow to get you over to the international office and checked in over there. It's important that you take care of this as soon as possible. Those of you who have not been to the U.S. before will be issued a temporary Social Security number, and I need that information so that I can process your stipend checks for the end of the workshop. We have a computer lab set up for you over in Schaffer Hall. We're going to go there shortly as soon as we're finished here. One item, pretty important item that I'd like to make you aware of is just security for that room, and also other security issues while you're on campus. The room is set up exclusively for our use over the next 6 weeks. The doors are intended to be kept locked while no one is in there, but you either have been or will be issued keys to access the computer lab. The team leaders will also be issued keys to access the building so that you can go in and out of there after hours, either in the evenings or on the weekends. There are file cabinets set up between each of the workstations that you will share with the person next to you. Those also have keys to them that are taped on the back of the file cabinet, so each of you can have a key. While we hope that the room stays secure and the security department is patrolling it for us, we strongly encourage you not to leave any valuable items, computers, cell phones, money, anything like that in the computer lab when you're not in there. There are a lot of other people who are in and out of Schaffer Hall, and sometimes the door to the lab does get left open, so we don't want you to lose any of your valuable items, obviously. Another security issue is just getting back and forth from the Broadview or the Colonnade to the campus. If you're here in the evening, or on the weekends, especially by yourself, there is a security van or an escort shuttle that will take you back and forth between the Broadview and the Colonnade. So please make use of it. You can get to that by calling the security office and just letting them know that you want to be picked up, and they'll tell you where to meet the security van, and they'll take you back and forth. So even if there's a couple of you, we would suggest later at night that you use the escort van. It's just much safer. We also have set up for you a lounge in Barton Hall. It's furnished with some comfortable furniture, a meeting table and chairs, a refrigerator, coffee maker, and we will try and keep the coffee machine supplied with obviously ground coffee, milk, sugar, whatever. We would just ask that you make an effort to keep the area clean. We will police it a little bit, but you guys will be using it much more than we will, so if you can keep the area straight, we would appreciate it. If you run out of any supplies, please let us know. There are also telephones in there for your use. They're set up to make local calls, either on campus or in the Baltimore area. Yes?
Did you issue cups for people this year?
We have ceramic coffee cups that some of you have already gotten. Those of you who haven't, we'll put a supply in the lounge. If you would just please mark your name on them and kind of reuse them.
We don't wash cups.
We don't. So we will have some extra ones for those of you who haven't already gotten one. As I mentioned, there are phones in the lab for you to use. You can make local calls at no charge, and you can also make long distance calls by using a calling card or a credit card. There's also a water cooler in there. You should be able to use that to get water for the coffee machine. And I think it also has a hot water tap on it so that you can use that for tea or instant soup or whatever. The room is checked occasionally by the custodial staff, and they'll take care of wiping up the floor. But again, all of the equipment that we've set up for the workshop is strictly our responsibility, so we'll need to police that to keep it clean. So if you need any supplies or anything, let us know. There's also a telephone in the computer lab that you can use same way for outgoing calls and also for incoming calls. The phone numbers for the telephone in the lab and also the telephones in the lounge are in your resource book, this book here. So feel free to use that number if you need to receive a phone call. We would just ask if you have the call come into the lab that you either keep it short or speak out in the hallway so that you don't disrupt the others in the lab. We will try and keep you up to date on all of the daily events that will be happening. We have a signboard that's posted in the lab, and we'll update that with the names of the speakers who are coming on Wednesdays or any other events that are taking place. If you also want to check and see what's going on a day-to-day basis, we do have a calendar on the webpage that Brian will keep updated, and also Sue and I can update that as well, just to add items to it. And I'll show you where it is. From this workshop page, it'll take you here, and then if you click on the individual day, it'll give you details for each of the events that are happening, the location, the time, etc. Let's take a look at today. Okay, here's information about today. And again, we'll update that on a daily basis so that you can see the details for each of the activities. As you can see tonight, we have a picnic planned. Hopefully the weather's going to hold out and we can actually be outside. And that's at 6 o'clock. I would suggest following the crowd. Most of us know where it is, and so those of you who don't, we'll get you there. And if If you want to have any events posted here, again, let Sue or I know, or you can shoot an email to Brian about that. We have a conference room available up in the CLSP lab that you can use if you wish to have small group meetings. But we also have use of 3 rooms during the day that the teams can kind of break out into to have their team meetings. The lounge is one of those rooms. There's a second classroom in Barton Hall on the main floor that you can use as well. And then the third room would be the computer lab. So there are spaces that you can go and separate into teams to have meetings. But if you wish to use the conference room, if you have a guest or something coming in, let Sue know and she can schedule that for you, or just make sure that it's available. As Fred mentioned earlier, we have breaks, cookie breaks that we'll have every afternoon. Depending on how things go this afternoon, we may or may not set up one. Just depends on whether or not everybody's scattered around. Normally the plan is that we'll set them up in the computer lab around 3 o'clock, and it'll just be a selection of cookies and sweets and some fruit and or vegetables. We would ask that you please try and keep most of the food away from the computer workstations, just so that none of the equipment gets damaged. We also have, as Fred mentioned, a lunch that will take place after the Wednesday lecture. That'll be back in the lobby and of Barton Hall and in the lounge. You are all invited to join the group for dinner on Thursday evening. It's a voluntary dinner, self-pay, and each week we'll try and go to a different area restaurant. We're collecting some menus already from different places, and we'll give you a couple of options and let you know where the dinner is planned, hopefully the day before, so that you can decide whether or not you want to go. And we're trying to get a count early in the day on Thursday so that we can let the restaurant know. A couple of times we've surprised them with groups of 20 and they're not prepared for it, so we want to try and give them a little bit more notice this year. On Friday afternoons, also, we'll have a social around 4 o'clock in the afternoon. That'll be back in the Barton Hall lounge. First one will be this Friday, and we'll just have a variety of desserts and sweets for you to sample. If any of you need to receive mail or faxes, we can handle that in the CLSP office. I believe the fax number is printed in your resource handbook, as well as our mailing address. Just make sure that if anybody does send you anything, that it says CLSP on it, and that it has your name, and it should get delivered to our office, and then we'll again track you down and make sure that it gets to you. We can also receive FedEx or UPS packages if you need to have anything delivered. There are some mailboxes set up over in the computer lab, one for each participant. So if we do get anything in for you, if you need to share information with each other, you're welcome to use those mail slots for that. As I mentioned earlier, most of you already have been issued keys. Others who have just arrived will be issued keys today, tomorrow, whenever we can track you down. You have a key for the computer lab. You will have a key for Barton Hall so that you can get in and out of the lounge. We will do our best to make sure that the lounge room stays unlocked, but occasionally security comes through and they'll flip the switch on the door, and so it'll be locked. If that's the case, you can call security and they should unlock it for you. They have a list of all the names of the participants, so they know that you're supposed to be there and that you're affiliated with the workshop, so it shouldn't be an issue. The team leaders, again, will also... Yes.
What about the key to get on the staircase to the main, to Barton 320?
That's also the key that unlocks, that will let you in and out of Barton Hall, or into Barton Hall. That key will work on the stairwell. That's mostly for the...
And it works on the elevator as well? Or?
Yeah.
If you can get it into the lock.
The 005 key works on the
I know, but everybody's getting the 005 key, is that right?
Correct.
All right. I have one more question.
Yes.
Is there a shuttle to Doroganda or anything like that? I saw there used to be something.
There is.
So that's important because some people want to cook and buy themselves groceries, etc. So
right.
So
yeah, there is.
So do we have a schedule or?
Is it,
how
it's
does
not
that
the
work?
escort van, is it that
No,
takes
it's
you
a
up
route
there?
van, and the schedule is on the web. As usual, nowadays, anything you want to know is on the web.
No, but I know, but you have to find the web page, right?
Yeah,
So we have it on
the
our,
JSU web
we have it on our web.
It's
No.
on the Hopkins web.
We
Well,
can put a link, we can put a link to that shuttle schedule on our webpage. No, the one that goes over to the rotunda. Yeah. I'm
What
sorry.
did you say?
I'm pretty sure that's not operating.
Okay.
Yeah, the escort van that usually takes you between the Broadview and here, their basic idea is anywhere within a mile of campus, if you have 2 points, they'll take you from point A to B.
Right.
So neither of them has to be on campus. You might want to go from the Rotunda to the Broadview, or from the Broadview to the Charles Village Pub.
Right. And they may ask you for ID again, so you'll get your ID card and you'll want to show that.
I think we want to facilitate it. In other words, somehow be helpful in knowing where to get the shuttle and all that. I mean,
Yeah,
I think it's not clear.
We'll put some information up on the WSO3 webpage as soon as we get it. So back to the keys, the team leaders will also have a key to access Schaffer Hall, where the computer lab is. So after hours, if the building is locked and you want to get in there, you can either contact one of the team leaders. First, I would suggest calling the phone in the lab and seeing if anybody else is in there and they can let you in. Or contact one of the team leaders, or lastly, check with security, and security should be able to let you into the building, and you'll have a key to the lab. The team leaders will also have a key to the CLSP lab in Barton Hall, and they can access there again after hours if you want to use the CLSP library, if you need to make photocopies or send faxes or anything like that.
I'd like to say that if this information is inadequate or you want some other services, we'll take it up in the steering committee. So if you have an idea that, that we could do something that we're not doing, we'll certainly consider it, tell it to your team leader, and then we'll have a discussion.
Most of you probably noticed on your way over here from the Broadview and the Colony that we have a few construction projects going on this summer again. Most of those should stay contained to where they are and not spill over into any other areas, at least as far as we know right now. So it should not impede your path from campus back and forth to the Broadview and the Colonnade. If we get any other information on that, we'll let you know.
Are the Wednesday talks going to be here, or do people have to watch out for where?
The Wednesday talks are in a couple of different locations. In July, they'll be in one location, and that will change in August. So they are posted on the webpage. Again, if you go to the calendar and click on the individual day, you can find out the location. For July, they're in Maryland Hall, which is the building just north of Schaffer Hall. And in August, they'll be in the Schaffer building, down one level in the large lecture hall in the basement.
And now we're discussing the 10:30 lectures, right?
Correct.
And so what about the team updates? Where are they?
Wherever the lecture is.
Oh yeah.
Yes,
we
so
can
we'll
keep
have that room all day. So on Wednesdays.
This wasn't always so, that's why I'm asking.
Right. On Wednesdays, we'll have the lecture in the morning. You'll come back to Barton Hall for lunch, and then you'll go back to wherever the lecture was for the team update presentations in the afternoon. The two closing presentations will be on Wednesday and Thursday, August 20th and 21st. We'll have presentations by all three teams, and we'll, as we get closer to that time, we'll work out the schedule and the agenda, and that'll be posted on the webpage. On Thursday evening, we will have our final celebratory dinner. And that will be held at a location a little bit north of campus, so we'll have to make some arrangements for people to carpool to get up there. And again, details about that will be posted on the web. On Friday, Friday will be spent breaking down the computer lab, so anything that you may have on your workstations will need to be cleaned off early Friday morning. And at noon, we'll have a farewell luncheon for everybody. At that time, we will collect your keys and hand out the final checks to those of you who are receiving funds from us. And after that, the computer lab will be broken down in the afternoon, so those workstations will not be available. We have to make that classroom available and put it back to its original state by midday Saturday, so we have to get out of there pretty quickly, as you can imagine. I think the only other thing I have, and Fred mentioned this earlier, is that on Thursdays, the undergraduates will meet with the CLSP faculty. That'll be at noon in the Barton Hall, or in the CLSP conference room, which is up on the 3rd floor of Barton Hall. There will be some information posted on the web, but basically it's a brown bag lunch. So bring your own lunch and you'll meet with the faculty members, and it usually goes about an hour or so. So I've thrown out a lot of information at you. If you guys have any questions, I'd be happy to take them now, or if you have anything later, Sue, Charles, Chris, and I are available by email, or just track us down in the hallway in passing and let us know what you need. Okay, I think Bill is going to say a few...
There may be questions.
Anybody? No? Bill's going to say a few words and give you some information about our computer systems and setup. Can you also cut this in? It's not going to be making here. It's only going to pick up the camera.
Hi. Every year they ask me to talk about the computers, and I'll do that, but I need to tell you, I don't know anything about the computers. So if you have a problem, don't send me email. I'll talk about what you should do. But this is a sort of layout of the network and the computers that we have. So we're behind a firewall, and this will no doubt cause you inconvenience, but that's okay, because the alternative is too bad to contemplate. So if you're coming in from off campus, you'll log into the SSH server. Off campus, that's called Speak, speak.clspjhu.edu. It's not called that from inside the firewall. Inside the firewall, it's called DCO2. Okay. Your home directories are on a Sun file server, DCO4. It's a RAID array, nothing particular about it. Everything is connected on a 1,000 base T network. We've created working directories for all the groups. No doubt you've started working in some already. There's 100 gigabytes devoted to each group, and the semantic annotation group has an additional 200 gigabytes. So we have a policy on keeping this data around. We keep it online for 2 years, and in 2 years it goes to tape and it goes offline. For 1 year, the idea is for 1 year you can sort of continue to sort of use it, but then it's just sort of there for archival purposes. The one exception is this directory here, the 200 gigabyte one that goes away at the end of the summer. So through the workshop, everybody will have these disks, and then after the end of the summer, we'll ask you to try to clean up a bit so that we don't have to keep all this stuff online and active. So we have a relatively large group of Linux compute servers. We have recently purchased IBM clusters of IBM nodes. Without much going into it, there's a FAQ, frequently asked questions page that tells you how to access the compute cluster, and some of the people on your team have already been using it, so hopefully you should just go to the people who already know how to use it. We have these, the way we go at distributing the resources is to use queues. So in other words, you could violate the queue and run your job on someone else's machine, and we rely on self-policing to avoid that. So if you're in a group and you see somebody from another group running jobs on your machines, you should complain. And similarly, people from CLSP will complain if you're using machines devoted to CLSP, and you should complain if people from CLSP are using your machines. In this way, well, it's like the legal system. Everybody's annoying. So that's that. Do ask for assistance. The idea is you've had grad
Is there a
students.
standard way of complaining?
No, people are so inventive.
I mean, at one point, it had to be done by email address to a particular
Yes.
address, and it had to have a subject.
Yeah, you should. Okay, so we have this mail alias, help@clsp.jhu.edu. So send all your complaints there. Yes, and you type in the, something related to the complaint in the subject line. But you should start by asking your graduate student for help, because they do all the work. They know how everything works.
That's why we had here for the last 2 weeks.
Exactly. There's a fact that has great useful information. We've been using a job scheduler called Grid. It seems to be working fairly well. But the best way to run jobs is to actually send a job to the Grid rather than try to circumvent it. And there's a description of how to do this on the FAQ. The one thing I would like to say is to please be careful about deleting files and directories. Many of you grew up using Windows, and so you're used to the idea that you can move things to a trash can, and it's there in the trash can. Unix isn't like that. You remove it, it's gone. And so you go to Jacob and you say, Jacob, I need this file back. Jacob says, well, I'll get it off the tape. It'll take a week. Okay, we make archives for recovering from catastrophes, like if lightning hits the building and we have to restore everything from tape. We don't make archives so that you can go find a file. So if you remove the file, there's sort of a cost-benefit analysis of maybe recreating the file, and if it takes 2 days to rerun the jobs and get the data, you're probably going to get it quicker than if you want it back from tape. So you've been warned. And the other thing is that, okay, so don't log into the file servers to run jobs. In fact, there are these file servers, and probably the load on them looks slow, and if you run in and you run a job there, that's great, you get a CPU, but all of a sudden people will notice that their disk access gets slower, so don't do that. Don't unplug the computers, don't power cycle the computers. They're on power strips with surge protectors. Don't plug in coffee pots or electric blankets or anything into those. And don't fill up the disks. And please practice safe computing. Don't share your accounts, don't share your passwords. I can't say this more plainly. Don't do anything stupid. We've had people take the password file and put it on the web server because they thought it was a good idea. We give you free run of the computer systems while you're here because this is what you need to do your work, but we're assuming that you're not going to jeopardize everything. There's just something about this university that attacks vandalism. I mean, people try to break into the networks and try to break the computers, and don't help them. That's pretty much it. Short of introducing the people who are here to help you. Jacob Latterman is the assistant administrator. He's in the back, and will stay in the back. And Dave Smith is with us for the summer to help. And Pete Keeler, is that your name? And John, your last name? Grimes, is with us, our student assistants. That's all that I had to say. You'll see the computers when you go over to Schaffer.
I think it's relevant to say when these people will be available. I mean, there is an almost 24-hour service, right?
Indeed.
So what is it?
Okay. We have evening and weekend coverage. John and Peter will be alternating. The calendar is posted on the wall in the lab, along with their cell numbers. So if they're not in the lab, you can always call their cell number.
It should be on the web too, right? So we can access it, and you don't have to go to the lab.
Did anybody verify if it's on the web?
I don't think it is, but we can put it there.
We can put it in the FAQ.
And just to reiterate a couple of things, the network this year is actually rather delicate. We have a private secure line from Barton Hall to Schaffer Hall, and nobody else is on it except us. The two network hubs that are in Schaffer are rather delicate, and if they get messed up too much, I'm afraid we're going to lose the network to Shafford Hall. So please don't plug in or unplug anything from the network hubs. Let one of us, one of the staff members do it for you. And this is especially critical for laptops, that once there are spare lines for laptops already plugged into the hubs, and that you should use one of those. I think everyone who has requested laptop access has already gotten their system set up. Coverage is roughly till 9 p.m. every night, except on weekends when it's 9 a.m. to 5 p.m. roughly. If no one's here at all, they may not be in Sheffield or Barton, but they'll still be available by cell phone to call them up, and they'll be within the area. The other thing that wasn't mentioned was that everyone has a 1 gig quota in your home directory. Don't store data files in your home directories. What should be stored, or a little bit more of what should be stored, would be your shell scripts that can't get recreated easily. And so you should have copies of them in your home directories. And I think this year we have almost everyone is already authenticated for your account, so setting up in the lab should be very easy. There are, I think, less than 8 people that haven't already authenticated your accounts. So we're much further ahead than we've ever been before.
Are you done?
I've done. Anything else? Any questions?
I have another question. Oh, sorry, go ahead.
Yes, Hamish.
I guess the grid thing only runs non-interactive processing. So if I want to run a big compute-intensive job with an interface, how do I do that?
If it brings up an interface, it'll set your X display, and it should display locally on your workstation. Nothing is saved locally on your workstations. If you save stuff locally, you'll never see it again.
But how do I know which compute service to use if I don't use the grid thing to run my...
There's a command called QSH that will open the shell.
Right. Okay.
It usually also tells people to continue using their home email and not to use CLSP for their email. Do you want to say something about that? That's all I'm saying.
It's pretty much preset where everyone's email from the group directories goes to their home email, and you can set your POP service to your home email sites within whatever program you use, either Netscape or I think there are 3 or 4 different web browsers and email readers, Pine, ELM, MailTool, and everything else.
Everyone has an ID.
Everyone's all set.
.jhu.edu, is that right?
Right, but we're asking people not to use them.
I understand that, but if I want to write somebody email, then where do I find their address? Is that on our webpage?
All the email addresses for the team members are on the webpage.
Okay.
And also there are mail aliases, so if you wanted to write to everybody in the workshop,
Yes.
there is a list of published aliases.
And that's also on the web?
That's on the web, definitely.
Who is on the...
Yes.
Yeah, okay. And one more question, which isn't to you, but to you. There used to be times when one of the student helpers, or whatever they are called officially, would be always in the lab. Is that a situation?
And that will be the case. Either Charles or Chris will always be in the computer lab, and
normally expected to answer the phone.
they'll answer the phone, right? During the day, normal work hours, 9 to 4:30 or so, depending on the day. And if they're not there, then one or the other of them will likely be over in the CLSP lab, and Sue and I are normally over there.
No, but I mean, we'd like them to
Yeah.
be there, right?
Yeah, generally they will be there.
And I guess they will run all sorts of errands too.
Yes.
I don't mean, to buy you frankfurters, but there are all sorts of things
right,
that
if you need
look
supplies,
for a person or
yes.
notify or whatever.
Right.
Turn to that helper.
Right. Find Charles or Chris, and they should be able to get what you need, or let Sue or I know, and we'll work it out.
Any questions? Do you want to say something?
Yeah, I did want to make a remark. I'm not ready for it. What I'll do is next time we meet as a group, I'll bring a campus map or something. This has to do with security. I mean, we are in the middle of Baltimore City, and so you'll exercise your usual good judgment, especially if it's after dark, about where to go, where not to go, and so on. By and large, within campus is very safe, and there's a little collar around campus where you can expect to be safe. And beyond that, I would just advise caution, nothing to worry about, just use the van and use your common sense. And I'll probably put up a map next time we meet showing where the eating places are and where to go and where to be careful. Oh, casino station, you already have one.
Oh, no.
Okay, well, I'll do it.
Do we have a number for security in the red book?
Yes, in general, the security number in case of an emergency is 7777. So it's, yeah, so 677-516-777-410-516-7777. And the escort van is 8700.
This one?
8700.
It's not security.
No, the first one's an emergency number. And the second one is an escort van number.
What's that number?
8700.
With a 6 in front of it.
With a 6 in front. 6 in front of
Yes. I just want to say, forget, what's the name of the guy from Karlsruhe and CMU who ran away from their, from his
Michael Finkel.
Yeah. So, you know, I mean, if you're good,
if you're athletic,
then you're pretty safe. But if you, so he was, I think he was, am I saying it right? I mean, he was jogging and somebody tried to mug him, but fortunately.
He was actually just walking to the lab and somebody tried to hold him up and, like, you know, he's just a good sprinter, so he ran away.
On the campus?
Just outside campus. No, you have to be careful. This was at 6 or 5 in the morning or something.
Or sleeping. We can't change Baltimore, unfortunately. I mean, we would change it to London or whatever, but it's Baltimore. Although I don't know how safe London is.
So the next agenda item is for everybody to reconvene over in the computer lab. Those of you who haven't authenticated your accounts can do so now, and you can get settled in your different group areas. We also have one other gift thing to hand out to you over there, so maybe that'll be a little bit of an enticement to get you over there. And then you can break for lunch, and you'll get back and have team meetings this afternoon.
And where various team meetings are
It's on your agenda.
and it's expected that you have